Alright, the homework solutions for day 2.1, linear relations. Let's see if we can make some sense of this chaotic diagram here. Over here we've got a bunch of elements of linear relations, and we're going to just match up the numbers with the correct values. So here we have number 1, which is pointing to the x-axis, the horizontal line on the Cartesian plane here. So we go ahead and put the x-axis up here beside 1. Number 2 refers to the y-axis, the horizontal line on the Cartesian plane. 3 is the origin, the point at which the x-axis and the y-axis intersect, and this is point 0, 0. Number 4 up here, we want the coordinates for this. And the coordinates are 3, 5. 5, the coordinates for this point, 3, negative 1. Number 6, the coordinates for here, this point right here, is negative 4, negative 2. Number 7, the coordinates are 6, 0. Number 8, the coordinates for this point right here is negative 3, 0. Now number 9 is asking the length of this line segment AB. Well, the length of this segment is 1, 2, 3, 4, 5, 6 units. And 10 is pointing at this line segment right here, CD, and it is 1, 2, 3 units in length. Here we're asked to plot 4 points, actually 5 because 1 is repeated. So here are the points that we're asked to plot. And then we're simply asked what shape that those points make once they're all connected. And the shape is, of course, a rectangle. When we plot these points and connect them, the shape shown is a triangle. Connect these points and the shape is a parallelogram. It's called that because this line right here is parallel to this line, and this line right here is parallel to this line. In this question, when we plot the points and connect them, we're given the shape of a trapezoid. And finally, on this one, if we plot the points and connect them, our shape is a diamond. Here we're shown 2 points and a line drawn through them, and we're asked, what is the slope of the line? Well, just by looking at our graph, we can count units and calculate our rise over our run. So to get from here to here, we need to head over along the x-axis a number of units, and then come up here a number of units on the y-axis. So we'll start with our run. There's our run. It's a run of 3 units, followed by a rise, a rise of 6 units, rise over run. Our run is 3, our rise is 6, and 6 over 3 reduces to 2, so our slope is 2. Here we have a line DC, and we count our run of 1 unit, followed by a rise of 3 units. So our rise over run will be 3 over 1, which reduces to 3. Here we have two coordinates, -1, 4, and 3, 0. So we start with a run of 4 units, followed by a rise of -4 units. And we call the rise -4 because we're going downwards. Our rise over run will be -4 over 4, which reduces to a slope of -1. Here we have two coordinates, G and H. So our run here will be 6 units, followed by a rise of -4 units. Once again, the rise is negative because we're going downwards. So our rise over our run will be -4 over 6, which gives us a slope of -2/3. And if we look at this slope of -2/3, it tells us that for every 3 units we move along the x-axis, we'll go down 2 units along the y-axis. We can check this by going 1, 2, 3, and then down 2, which takes us right back to the graph. 1, 2, 3, and then down 2, which takes us to the graph. So that's literally what a slope of -2/3 means. For every 3 units along the x-axis, we'll move down 2 units along the y-axis. Here we have two coordinates, V and W. Starting at V, our run will be 4 units, followed by a rise of -16 units, making our rise over our run -16 over 4, which gives us a slope of -4. Here we have two coordinates, S and T. S moves 10 units over to the right along the x-axis, followed by 4 units up to bring us to the T coordinate. So our rise over our run is 4 over 10, which further reduces to 2 over 5. And once again, our slope of 2 over 5 can be shown on the graph as 1, 2, 3, 4, 5, followed by a rise of 2, 1, 2, 3, 4, 5, followed by a rise of 2.